When you type a website's name and hit enter, you picture a simple thing. Your computer reaches across the internet and talks directly to that website, the way you might walk up to a shop and open the door. It feels direct, personal, just you and the site. But for most of the big internet, that picture is wrong. Long before your request ever reaches the website you are trying to visit, it passes through a checkpoint, a vast invisible layer sitting in front of millions of sites at once. And for an enormous slice of the traffic that hits that checkpoint, this is exactly where the journey quietly ends. No error you would notice, no announcement, just a request that never makes it to the door it was aiming for. That is what this video is about. The silent wall in front of the modern web, how it decides who gets through, and why almost nobody knows it is there. The naive picture starts with the thing most people believe, because it used to be true. In the early web, your request really did travel more or less straight to the computer running the website. One machine, somewhere, answered when you knocked. That simplicity is gone for any site of real size. The reason is partly speed and partly survival. A single machine cannot serve the whole world quickly, and it cannot withstand the modern internet's floods and attacks on its own. So a layer grew up in between, a network of machines spread across the globe whose job is to stand in front of the real website and handle the world on its behalf. You almost never talk to the website directly anymore. You talk to its bodyguard, the edge. This in-between layer is often called the edge because it sits at the outer edge of the network, close to users, far in front of the actual site. Picture a chain of identical checkpoints scattered across every region of the world, each one a copy standing guard for thousands of different websites at once. When you reach for a site, you are routed to the nearest checkpoint, not to the distant origins. That closeness is what makes the web feel fast. The content is cached nearby, but the same position that makes it fast also makes it the perfect place to inspect traffic. Everything bound for the website has to pass through this point first, which means this point gets to look at everything and decide what is allowed to continue. Elwin Fantista, he helps to understand the edge was not built to be a wall. It was built for speed. Putting copies of a site's content close to users all around the world makes pages load faster, which is reason enough to exist. But once you have a layer that every request must pass through, sitting in front of the real site, a second purpose becomes irresistible. If everything flows through this point is the natural place to filter. So the speed layer quietly became the defense layer too. The same machines caching the website to make it fast were perfectly placed to screen out the traffic that should never reach it at all. One piece of infrastructure, two jobs, and the second one largely invisible to ordinary visitors. The flood control. The first and bluntest job the edge does is absorb sheer volume. One of the oldest attacks on the internet is simply to overwhelm a site with a tidal wave of junk requests until it buckles under the load. A lone website cannot survive that, but the edge spread across the whole globe with enormous capacity can soak up an astonishing flood and keep standing, spreading the blow across all its checkpoints so no single one breaks. So before any clever inspection happens at all, the edge is doing crude crowd control, holding back the stampede so the real careful filtering can happen calmly behind it. It is the difference between a shop with a single nervous clerk and one with a calm, practiced doorway built to handle a crush. The reputation filter. Once the flood is handled, the screening gets smarter, and the first smart check is reputation. Every request arrives from a network address, and the edge, because it sees traffic from millions of sites, has an enormous, constantly updated picture of how each address has been behaving across the whole internet. Has this address been hammering sites elsewhere? Is it part of a known pool used for abuse? Has it shown up doing suspicious things in the last hour on completely different websites? A visitor with a clean history sails through. One trailing a recent record of bad behavior gets extra scrutiny, or a quiet door in the face. And crucially, the edge knows this from watching everyone at once, a view no single website could ever assemble alone. The fingerprint filter. Reputation is about where you came from. The next layer is about how you introduce yourself. When any connection is set up, The software making it reveals a great deal in the very first moments. The exact way it negotiates the encrypted link, the precise order and shape of the technical details it sends. A real browser produces a familiar pattern here. An automated tool wearing a browser costume very often produces a pattern no real browser would ever send. The Edge reads this opening handshake and compares it against what genuine browsers look like. The address might claim to be an ordinary home connection, but if the handshake says automation, the two stories do not match, and the mismatch is exactly what this layer exists to catch. The challenge layer. Sometimes the Edge is unsure, and rather than block or allow outright, it asks a quiet question. It issues a challenge, a small test the visitor's software must complete before being let through. For an ordinary person on a normal browser, this often happens completely invisibly. A brief check passed in the background that they never even see. For a crude automated program, the same test is a wall, because it cannot do the thing a real browser does without thinking. This is the layer most people have brushed against without understanding it. The occasional spinning "please wait a moment" screen. That pause is the Edge quietly running its test, deciding whether the thing knocking behaves like a real browser or only pretends to be one. The behavior layer, and beyond any single request, the Edge watches patterns over time. Because the most revealing signals only appear across many interactions. One request can look perfectly innocent in isolation, but the Edge sees the whole crowd. It notices when a single source pulls pages far faster than a person ever could. It notices when activity arrives in perfectly even intervals around the clock, with no sleep, no pauses, no human rhythm at all. It notices when a swarm of fresh visitors all take the exact same path through a site at the exact same speed. No single fetch is the problem. It is the shape of the behavior over time. And this is the layer where scale, which feels to an automated operator like strength, quietly becomes the very thing that gives it away. Not every bot is unwanted. It is important to say that the Edge is not trying to block all automation, because a great deal of automation is welcome and even necessary. The search engine crawlers that read the web so you can find it are programs. The services that check whether a site is online, that fetch a preview when you share a link, that monitor for problems, all programs. So the Edge is not asking the crude question, is this a human or a bot? It is asking the subtler one, is this a bot we want, behaving the way it should, or an unwanted one pretending to be something it is not? The welcome ones declare themselves honestly and can be verified, and the Edge waves them through on purpose. The trouble is reserved for the automation that hides what it is. The wall is not anti-machine, it is anti-deception, and that distinction is the whole art of doing it well, because block too much, and you wall off the helpful readers the site actually needs. Why centralization matters. Now step back and notice the deep reason all of this works so well, because it is the whole point. These edge networks are shared. A single one stands in front of a huge fraction of the entire web. That means it sees traffic for countless sites simultaneously, and it learns from all of them at once. An address that misbehaves on one site is instantly suspect everywhere that network protects. A new automation pattern spotted attacking one customer becomes a known signature defending all the others within moments. No individual website could ever build that picture alone. The centralization that some people worry about, for good reasons, is also exactly what gives the defenders such an overwhelming view. The wall is strong because it is watching everyone, everywhere, all at the same time. The arms race, and who has the advantage? Of course, the other side adapts, as it always does. Operators of unwanted automation work to soften their handshake so it looks more like a real browser, to spread their requests across many addresses so no single one looks busy, to slow down and mimic human rhythm. And the edge responds, finding the next tell, the deeper fingerprint, the subtler pattern in the crowd. It is the familiar endless back and forth, but the advantage sits heavily with the defender here, for a simple reason we keep returning to. The imitator has to look flawless across every single layer at once. The reputation, the handshake, the challenge, the behavior, the edge only has to catch one thing out of place. And it gets to watch the whole internet's real traffic for free, every day, so it always knows exactly what genuine looks like. The double edge. It would be dishonest to pretend this is all clean and good, so let us name the tension. The same wall that absorbs attacks and blocks abuse is also a single, powerful gatekeeper standing in front of a huge part of the open web. When it works, you never notice it, and the internet is faster and safer for it. When it misjudges, an ordinary person can find themselves quietly locked out of a site for no reason they can see, caught by a reputation they inherited from a shared address or a check their setup happened to fail. Concentrating so much of the web's traffic behind a handful of these layers makes the whole thing faster and more defensible, and also gives a small number of operators enormous quiet influence over who reaches what. That is the genuine double edge, and it is worth seeing clearly rather than pretending it away. What it is really about. So here is the part to sit with. The internet feels like a place where you walk straight up to the sites you visit. For most of the big web, you do not. You pass through a silent bouncer first, a global layer that checks your reputation, reads how you introduced yourself, quietly tests you, and watches how you behave, all in the fraction of a second before the page appears. Most of the time it waves you through so smoothly, you never know it happened. But it is always there, deciding, and understanding it changes how you read the modern internet. The web is not a set of doors you knock on directly. It is a set of doors behind a wall. And the wall, not the door, is increasingly the thing that decides whether you get in. And once you have seen the wall, you start to notice it everywhere, in the brief pause before a page loads, in the occasional check you are asked to pass, in the strange lockout that makes no sense until you realize you were judged before you ever arrived. If this is the kind of thing you find yourself thinking about, the quiet machinery under the everyday internet, then this channel is your sort of place. There is no product to sell you here. It is just the systems, taken apart and explained by someone who has spent a long time on the inside of them. Subscribe and follow the rabbit hole. Next time we are going to look at the very first thing your device does before it can reach any site at all. The quiet question it whispers to a stranger to turn a name into a number. How that lookup quietly reveals everywhere you go, who can read it, and the defenses that close the leak and the ones that only seem to.